So let's consider a second example problem for thin film reflection. So suppose you have a substrate, okay, so something like glass, so N equals 1.5, and then you have a thin film on here, and the thin film is some optical coating, let's say 1.35, and then you have air up here, so N is approximately 1. Okay. Now, what I want is, I want light shining off of this. I want to transmit the maximum amount at a wavelength of 900 nanometers. That's infrared light. On the other hand, I want to have minimum transmission. I want to have minimum transmission at 450 nanometers. So that's kind of a bluish violet color. And so we want to have the least at that and the maximum at 900 nanometers infrared. So this would be like an infrared camera or something, and we don't want to saturate it with blue light. So what do we do? Well, same situation here. We have that we want to have a situation in which we have the maximum transmission. So maximum transmission, that means the minimum reflection. And we want that to be at 900 nanometers. That's going to be your lambda naught. That's going to be the wavelength in the vacuum. It's about the same as the wavelength in air. Okay. And so we want to have the minimum reflection. So that means that we want 2L m plus 1/2 lambda naught over n. Okay. So L is going to be equal to m plus 1/2 lambda naught over 2n. Okay. And lambda naught, 900 nanometers, n is 1.35, so this will be L equals m plus 1/2 900 nanometers over 2 1.35. Now, m can be a variety of things right here. So m can be equal to 0 or 1 or 2 or 3 or so forth. Okay, so if m equals 1, if you plug in the numbers here, then what you get is 167 nanometers. Okay. And then you also get 500 nanometers if n equals 1. If n equals 2, it's 833 nanometers, and so forth. Okay. And so we just keep going in here. So the next one would be, it turns out we're not going to need that, but you could just keep on going and just keep going. Okay. So any of these would work. But we have another condition that we want to meet. The other condition that we want to meet is that we want to make sure that we get maximum reflection at 450. So that means that we want 2L equal to m lambda over n, so for 400 nanometers. Sorry, 450 nanometers. Okay, so that means L equals m lambda naught over 2n. Okay, so this is going to be m times lambda naught, 450 nanometers, divided by 2 times 1.35. Okay, so once again, m can be equal to 0 or 1 or 2 or 3 or so forth. Okay, so if m equals 1, obviously the thickness is 0. Okay, so if m equals 2, the answer comes out to be 167 nanometers. If m equals here, if m equals 1, it's 167 nanometers. If m equals 2, it's 333 nanometers. If m equals 3, it's 500 nanometers. And so we want to match this. And so we say we want this condition to be met, and we want the other condition to be met. And we find that, well, the condition is met for both of them at 160 nanometers. So that would work. The conditions also met for both of them at 500 nanometers. So that one would work also. And then there's others that would work too, but this would be the thinnest one right there that would work for both. And so this is how you'd figure out if you need two conditions to be met, then what you do is you just find out all the m's that make one condition meet, find all the m's that make the other one condition meet, find the thicknesses, and then look at the two lists and find which numbers agree on both lists. So the one we did here was really simple. If you had a little more complicated, then you might have to go through dozens of different m's on each one of them to find the first one that matches, that both conditions are met. I would recommend not necessarily doing that with pencil, paper, and calculator. Notice this is just a repetitious sort of equation. So if I were you, I would use Excel and just say, m equals 1, 2, 3, 4, 5, just have it increment down and then plug into an equation that does it, and it does all the calculations for you, and then you just quickly look at the two columns and see which one matches. So that's how I would actually do this in real life, rather than doing it as calculating each one of them individually until you have an agreement. But this is another example problem here. Okay. Next thing we're going to think about, though, would be what if the phases are different.